Hi, my name is Don Briggs, and I am the member of the team at Breadboard Electronics who has been volunteered to create these short presentation videos. This is the first in a fairly large series of short videos to get you interested in experimenting in electronics. All of the videos are based on the components in our starter kit, which can be found at breadboardelectronics.co.uk. General format of the videos will show you not much chatter like I am doing now, but it will show you a circuit diagram and show that circuit working. Then I show you a breadboard representation of all components and show that working too. Later on there may be one or two circuits that do not have a breadboard representation. This is because of the limitation of the software that we use. But hopefully by that time even the complete novice will be able to convert a circuit diagram to their breadboard. There may, but more likely not, also be an explanation of the circuit mathematics. The assumption is that you have some kind of formal learning material to hand, whether that is a school textbook or library book, it makes no difference, or you just may not want to do the maths anyway. The premise behind Breadboard Electronics is not to force maths upon you, but offer working circuits to you for experimentation. We are not here to take the fun out of learning. We are not here to bore you with detail. We'll leave that up to others. We appreciate that watching someone build a circuit before your eyes can be a little tedious, so we will show you various screens for a few moments, a bit of chatter about the circuit, the breadboard, etc. Then leave it up to you to pause the video, study and copy at your leisure. There is also a downloadable book in the PDF format for a modest price available from breadboardelectronics.co.uk, which contains images taken from the videos as well as any maths hints that we may have used, so that you can have an exact copy, scribble on it, change the component values, experiment, etc. etc. Now, without further ado, Project 1 is the hello world of electronics. An LED is turned on and off. Yes, very basic, but we have to start somewhere. All of the circuits presented all of our circuits are presented in a similar fashion to this, showing the components required, the circuit itself, and some text. Most do not have this amount of text, some have virtually none. Breadboard Electronics is about the circuit, not about the theory. We have a switch, a resistor, an LED, and all this is connected up to a battery or a power source, whichever you have. The resistor is used to reduce the voltage through the LED so that it does not blow. A typical 5mm LED can only handle about 2.5 to 3 volts depending on their colour. So you might want to look at the data sheets for the colours if you really want to, but we have used a 330 ohm resistor because it will suffice for all colours of the 5mm LEDs. If I turn the switch on, the power will go to the LED. We'll just show that now. Turn it on and then turn it off. Turn it on, turn it off. This is the general layout of what we will do in our presentations, and I will now leave that screen for you to read if you want to. I'm not going to bore you with reading it. So you might want to pause it just in case you really want to. Next, this is the breadboard representation of that same circuit that we've just seen. Again, this is exactly the same format as we will use for all of our videos. It shows the circuit on the first screen and then we'll move on to the breadboard itself. All of them have a parts list at the top, which gives you an idea of what's required. A little bit of chatter maybe, or maybe not. Now this particular circuit, again, you can start it somehow. It doesn't want to start. We have a switch, a resistor and an LED. We flick the switch on, the LED goes on. We flick the switch off, the LED goes off. As simple as that. Now, here is what I use for testing my resistors. At the end of the day, I can have loads and loads of resistors lying around on the workbench, and my eyesight is not that fantastic, so I have trouble seeing the colours, so I just don't bother anymore. But what I have is a breadboard, a spare breadboard as the case may be, with two bare wires running down the side, and connect those directly into the multimeter. Then I just push a resistor onto the two wires, check which one it is, and hopefully, I want to run this again and it's not playing, so hopefully it will show me the resistance of that particular resistor, and if I put another one on there, it will give me a different one. I might have to change these values here to get the right one, but that is basically how it is. Now, this video is the only one where I'll show you a little bit of Ohm's law, I hope. There might be one or two other sums involved, but generally this is it. Just to give you a taster of Ohm's law and to give an explanation how we got to the 330 ohm resistor. Technically it's 175, but one could argue that it's between 75 and 1k. But generally 330 ohm resistor will protect your LED. And we don't want to lose our LEDs. They're important to us, so it's important just to know one or two little facts. This resistor goes with a LED all the time, every time. If you then create a circuit and you look at it and you think, well, that's a little bit dim, check the voltage across it first to see if it's sort of between 2.5 and 3 volts. If it's not, then what you really want to do is just lower the value of that resistor. Thank you for watching.
Hi, this is Project 1, Turn on the LED, Hello World. Here we have our little switch to turn the circuit on. We have a 330 ohm resistor and a red LED. The 330 ohm resistor is man enough to cope with all the different colours of LEDs that you're likely to use, bearing in mind that the different colours will have a slightly different forward voltage to others, and using a 330 ohm we know will protect all of them. Another thing to remember with LEDs is that they have two pins, a long pin which is the anode and a short pin which is a cathode. Now the anode must point towards the positive side of the circuit, otherwise it will not work, because it is, after all, it's a diode. It must be plugged in the right way round. Right, now this little circuit, if we flick the switch, the LED comes on, and we flick the switch again, the LED goes off. It's as simple as that. There's not much I can say about this circuit other than to look forward to using something very, very similar over and over again in your projects. Thank you for watching.